Welcome to a new test and teardown video. This time it's a function generator from BWD Electronics Australia. So it's a long way from home. And we got quite a wide frequency span. And we got many different outputs at the same time. I think you can actually do both TTL and any of those waves on that output, but you can also do all those outputs here at the same time, as far as I've been able to Google around. I'm a little bit sad that I don't see any ground connector here at the back, so you need to have a wire all the way from the front. That's a little bit weird. The metal seems very thin, as you can see here. Super thin metal. It's not a heavy duty top class quality product. It's not like that really, but a little sexy hobby generator, definitely. I tried to set this for sine wave and no DC 1 kilohertz. Let's try and power this up and see if it works. So I think I have set this up for testing. It says pull for power on. That's a little bit funny. Okay. And that is the amplitude. Oh, I have enabled. Oi. Why is it looking like that? Is it that one? Okay. So this is a resistor that just needs a little bit of massage. And you know what? If you look... Come on, man. So, okay, now it's stable for a second. If you look at the top here, let me go a little bit closer. If you look at the top of the curve, you see this little pointy little dot up here, and it's down here as well. And this tells me actually exactly what kind of chip this is. I already published a video about this a generator, multi-purpose function generator IC, and the first released models of that IC got exactly this problem. It is a known bug, and they actually changed this in a later version. So let's open it and see what kind of chip that is. Yeah, you see, we got a little bit of loosey connections, and that is why we see this kind of funny stuff here. It's doing the wobbly. It also got a voltage control input. It can do, yeah, all the different shapes. Square wave. Okay, you need to unclick the other features. No. I don't understand exactly what is going on here. Okay, so this is not what it shows on the front. It's actually times 10. And then it is a pulse width kind of thing, right? Yeah, that is something funny. And in sine wave mode, it's doing some funky. Well, this is like completely full of loose connections. I bet most of this is related to the pot meter or the switches. I'll try and see if I can clean this up. Whoa. Oh, that looks like mains. See? That. It looks like 50 Hertz. So we have a power supply capacitor or something like that, right? Yes, teardown time. This is actually a little bit fun, because I was actually wrong. It's not this multifunction IC, it's just a design with op-amps and stuff like that. It's all super standard stuff here. It's not this multi-purpose function generator IC that I was expecting. So it's just made more or less the same way. That's a little bit funny. See, we got two op-amps down there in the same socket, and here is a temperature. I think this is an NTC or something like that, soldered directly to two diodes. So there you have a temperature compensation circuit. We've got two transistors here that's thermally connected for output stability. I'll look at the range capacitors. They cut some adjustments down into the capacitors. Really bad. This is exactly how you short circuit the capacitor. I mean, this can't be good. Well, I'll try and change the capacitors here and see if I get a little bit more stable output, because I definitely think this ripple here affects output. But other than that, it's quite a beautiful design. We got some transistors for power supply. Look at that detail, mounted here on the aluminium instead of being mounted on the PCB. Plus and negative power supply, so of course you want to do it like that. This is a good thermal design. I kind of like it. It looks a little bit funny, but this is definitely a good design, instead of having a red glowing hot component here and then you need to bugger around with heat sinks and whatnot. It's much better to have the cables out here and then mount your transistor where it is really good cooled. Yeah, and those are a little bit rusty, those springs, so this tells me I definitely need to clean those contacts as well. But it's actually, yeah, quite beautiful design. Other than this capacitor cut, I'm not happy about that. And the PCB layout is also quite beautiful. BWD Electronics, Melbourne, Australia. Revision 9. So how old is this thing? 75, really? Oh my gosh. How about that one? Yes, 73. Oh, no way. Okay, then I definitely need to change the capacitors. Quite alright. That's a good way to protect the fuse. Look what I did. I changed the two capacitors and look at the output. I think, oh, I still have a little bit, so this is the pot meter. But definitely, yeah, at some frequencies I still see this pot meter kind of stuff. And there you have it. I also massaged those switches. I think I actually didn't add any cleaning chemicals yet. I was just massaging them because I can see that I get a little bit of a different waveform now and then. See, it's the same here with the different frequency settings. But there's definitely hope for this one compared to the first little test. I think I'll just clean it a little bit more, and then I got myself a really nice function generator. I'll try and test all the other outputs as well. So let's test a little bit on the frequency range of this unit. Yeah, we got 7 different ranges, and I am now in the lowest frequency range, and I dialed it all the way to lowest possible. And now here, look at this. It's not a perfect sine and all that, but here is the frequency, 47 millihertz. So that's a very low frequency. If you Google this unit, you will find that many sites actually explains the highest frequency to be 20 megahertz, and that is of course not true. It is only 2 megahertz. Let's try and see if that is. Yes, it is. Here you go, your 2 megahertz. So that is of course the frequency range, and I don't know if you saw this, but the output amplitude is very close to being the same, so that is super nice. And after I cleaned the contacts and worked a lot with the potmeters and all that, I now got a nice and stable machine. So I'm quite happy about that. So now I'm testing all the different outputs more or less at the same time. So we've got 3 outputs on the back. Sine, triangle, and square wave on the back, and the square wave on the back is inverted in relationship to the TTL output on the front. So that is what we're looking at here, the 2 square wave outputs. I'm looking here at 1 megahertz, so it is about only a little bit away from its maximum potential. So this is why you see the rise times here and stuff like that. So this triangle. And then there's a sine wave. It's the same sine wave there is on the back. So all in all, it's 4 different waveforms it can output at the same time. And not, I don't know how many you see if you Google this product online. So that is of course not true. So thank you very much for watching. I hope to see you soon. Bye bye.